Greetings, professors. I am Anuj Pratap Singh of K Batch, roll number 44, and I'm going to explain the working of carburetor. The carburetor meters and delivers fuel to the engine under all conditions. It is made to function by the air drawn through the air intake by the engine. The speed of air which moves through the carburetor is determined by the speed of the engine. There are various types of carburetors, but firstly we will discuss a single jet carburetor. In a single jet carburetor, there will be a venturi, a throttle, a jet, and a flow chamber which contains the fuel. The flow of air through the venturi causes a pressure drop which pulls petrol from the flow chamber through the jet into the airstream. The flow of fuel is controlled by the difference between the pressure and the nozzle of the jet and the atmospheric pressure in the flow chamber. The size of the pressure drop governs the operation of the engine, which responds to the position of the throttle. However, such a carburetor does not meet the need of modern day car. The job is to deliver the right mixture of fuel and air under all conditions and to keep the mixture in correct proportion, for which more air needs to be introduced. This is done by air bleed. Air bleed restricts the amount of fuel reaching the engine by mixing more air to maintain the correct mixture. The air bleed consists of special channels within the carburetor, and the flow of fuel through the main jet draws in additional air. Cold. When starting from cold, a richer mixture is required. Here the choke plays an important part. To start the engine, the choke is closed, which slightly opens the throttle. The choke valve allows very little air to pass. So when the engine is turned over, the suction acts mainly on the fuel jet and together with the small amount of air produces a richer mixture for starting when cold. At normal idling speed, the suction is not strong enough to pull sufficient fuel into the venturi to keep the engine running. To do this, a small amount of petrol is injected into the side of the throttle nearest the engine. This is idling jet. The petrol is delivered from the flow chamber, air is drawn from the upper part of venturi and sufficient mixture is provided for the engine to run. Normal acceleration, a progression jet provides more petrol until the normal jet takes over. The sudden throttle opening provides more air but weakens the mixture. There is a lag whilst extra fuel is drawn into the venturi to meet the new condition. At the accelerator pump, by injecting a quantity of fuel into the airstream, restores the mixture strength and sharp acceleration can take place. Now we will talk about another type of carburetor, which is variable jet carburetor. One side of venturi is replaced by the bottom of the piston, which moves up and down in a finely machined cylinder. When the engine is at rest, the pressure on both the underside and top side of piston is atmospheric and therefore equal. With the engine running, air is drawn out of the interior of the dome, the pressure falls and the piston is lifted by the greater atmospheric pressure below. When the engine stops, the air flows back again and the piston falls. Air pulls droplets of petrol into the venturi, and to regulate the flow, a granulated needle is held by the piston in the jet. As the throttle opens, air is drawn through the carburetor, the piston rises and the fuel is pulled into the airstream. For cold starting, there is a disc valve operated by the choke in which a series of holes of different diameters are drilled. The choke controls the rotation of the disc into the full ridge position. All holes are open to the flow from the flow chamber. As the engine warms up, the choke is pushed back in. Fewer and smaller holes provide the fuel and the mixture returns to normal. Now let's talk about another set of carburetors, which is twin choke carburetor. In high performance vehicles, maximum power is obtained by drawing in as much mixture to the cylinders as possible. A single carburetor is not always sufficient, and one development which meets the need of this is a twin choke carburetor. It consists of two carburetors of different diameters side by side in the same casting. At lower revolution, the need of the engine are met by the smaller diameter carburetor. At higher revolution, the larger diameter carburetor comes into play and increases the intake of mixture, which in turn increases the performance. Till now I have discussed three major types of carburetors. The task is always the same, which is to deliver the right amount of mixture of air and fuel to the engine at precisely the right moment. Thank you, that will be all. I hope you enjoyed